Okay, so this is another problem where we have to state we have to investigate the function and then state the discontinuity where if they exist at all, right? So when you have a function like this, um, there are a couple of things that you can check to see where the discontinuities are, right? So, well, um, first of all, it's a great place to start is to check if you're dividing by zero at any point. So here you can see that, okay, well, if t equals 1, so here if t equals 1, then g of 1 is 1 over 1 minus 1, which is 1 over 0. So that's not allowed. So there's a discontinuity at t equals 1, right? But also notice that this is t squared, right? So this applies for t equals minus 1 too. So if t equals minus 1, then g of minus 1 is 1 over 1 minus 1 squared. So this is 1 squared, right? Which is again, this is minus 1 squared minus 1. So this is again 1 over 0. So discontinuity at t equals minus 1, right? So we have a couple of points that might be interesting, right? And furthermore, we could also look at what happens as t approaches infinity, positive infinity and positive infinity, positive infinity and negative infinity. Okay, so how's this function behaving as t approaches positive infinity? You can see as t gets really big, this minus 1 becomes inconsequential. This minus 1 in the denominator becomes inconsequential, right? So as t gets bigger and bigger and bigger, this function goes to 0, right? So the limit of g of t, let's just have some fun with colors here. No, it doesn't matter. Okay, so the limit of g of t as t approaches positive infinity is 0, and the limit of g of t as t approaches negative infinity is also 0. So make sure that you understand why this is the case, right? Because as t gets really big, this becomes a huge denominator, and this gets smaller and smaller and goes to 0, right? Okay, so we have some information now about how the function is behaving at certain points, right? And we're looking for any of these discontinuities in this. I've written out here in purple. Is it a jump discontinuity, a removal discontinuity, or an infinite discontinuity, right? So let's just plot these out and see what these look like. So I'm just gonna draw the axes, right? And this is gonna be x, and we're interested in, well, okay, I'm just gonna put a box around these just to highlight them, right? So we have a discontinuity at t equals 1 and a discontinuity at t equals minus 1. Okay, so let's see. First at t equals 1, so I'm just gonna pop this 1, 2, 3, minus 1. Minus 2, minus 3. Okay, so let's see, at t equals 1, we have a discontinuity, right? So this function is not defined for t equals 1. So we need to figure out, okay, well, what's happening as you get closer and closer to t equals 1. So just because a function is not defined at t equals 1 doesn't necessarily mean that it doesn't have a limit there, right? So let's see, the question is, what is the limit of g of t as t approaches 1, right? So, and we need to investigate this from both the left and from the right. Okay, so let's look at the function as it approaches t, as it approaches 1 from the right. As we get closer, and so I'm just going to rewrite what g of t is. So g of t is 1 over t squared minus 1. Okay, and you can see that as t, so we need to see what's happening as you get closer and closer to t from the right, 1 from the right. So basically we have a number line, okay, and this is 1. We're trying to figure out, okay, what's happening as we get closer from the right as well as closer from the left. Okay, so in this case, let's look at what happens when you get closer to from the right. As you get closer and closer to 1 from the right, so we have numbers like, so let's say t, okay, and g of t. Okay, so let's say we have numbers like 1.01, 1.001, 1.0001, right? And we can see what's happening to the function, right? So we can, as we get closer and closer to this value, so we have something like, so what's 1.01 minus 1, that is 0.01, so 1 over that answer, so this is 100. Okay, this is 100, and then this is going to be 1,000, I'm pretty sure. So 1 minus, so pardon me, sorry, we need to square this, right? So it's 1.01 squared minus 1, which is minus 1, and then that 1 over that answer, which is something like approximately 50. Okay, and let's say, sorry, the 1.00001 squared, that answer minus 1, then 1 over that answer. This is approximately 500, right? And you can see where this is going, right? So if you have 1.0001 squared, right, and then from that answer we subtract 1, and then we divide 1 by that answer, we get approximately 5,000, right? You can see as we get closer and closer to 1 from the right, this number shoots off to a huge positive number, right? So what does that mean? So that means as we get closer and closer to the right, from the right, this number shoots off to this way. Okay, so that's one thing. Now let's investigate this as, so this is positive infinity, right? This number goes off to positive infinity. So what about the limit of t as t approaches 1 from the left? Okay, so now we're looking at this. So this is from the right, this is from the left. So from the left you're looking at, so t, g of t. Okay, so this is going to be numbers like 0.99, 0.999, let's say 0.9999, make this a bit clearer, 0.9999. Okay, so we have 0.9 squared, 1 minus that answer, right? And then 1 over that answer, you get minus approximately 5.2. Then we have 0.999 squared, that answer -1, and then 1 over that answer. You get, oh sorry, then probably made a mistake here. Wait a minute, just double check. 0.99 squared, 1 minus the answer, then 1 over that answer. Yeah, it's approximately 50, right? So this is approximately 50. Then this is also approximately 500. All right, and this is approximately 5,000. Negative 550, negative 500, negative 5,000. Okay, so just to double check, 0.9999 squared minus 1 over the answer. Yeah, so these negative numbers, right? So as t gets closer and closer to 1 from the left, we are going off in the negative direction. So let's just, I'm just going to draw this, what is going to be a vertical asymptote at 1. Okay, and as we get closer and closer to 1, we can see that this number shoots off into infinity. Okay, so that's the behavior at 1, and it'll be, I'm not going to work through it here, but it'll be obvious, it'll be similarly obvious to you that if you repeat this for -1, you get the same sort of behavior, right? You have but okay, for completeness, let's just work through that as well. So now we know that, so we have investigated this behavior now at t equals 1. Now let's investigate the behavior at t equals -1, right? So we're looking at a number line, okay, and we have -1 here, and we're looking at how this function behaves as we approach -1 from the left, right, and then from the right. Okay, so t again takes let's say negative values, right? So -1.01, -1.001, -1.0001, right? And g of t, so we're approaching this, so this is approaching from the left, right, whereas this is approaching from the right, because as you know, as you move this way to the left of the number line in negative direction, it gets bigger and bigger, right? So we're coming towards -1. So minus 0.1 is a larger negative number than -1.00. So -1.001 is a bigger number than, larger number than -0.01. Right? Okay. So if we repeat this calculation again, we get something similar. We have 1 minus 1.01 squared, 1 minus the answer, 1 over the answer. Wait a minute. Minus 1.01 squared minus the answer. 1.01 squared minus 1, 1 over the answer. So approximately 50 again, right? And then this is going to be approximately 500, and this is going to be approximately 5,000. Okay, so as we get closer and closer to -1 from the left, right, this number shoots off to a large positive value. So this again is going to be a vertical asymptote right here. Maybe I should do this in a different color, but anyway, so this shoots off to a huge positive number, right? And in the same way, this is gonna shoot off to, so if t is g of t, and then we have negative 0.99, negative 0.999, negative 0.9999, right? This is going to be approximately a negative 50, approximately negative 500, approximately negative 5,000, right? So this is, again, as we get closer and closer to -1 from this side, from the right side, we get something like this, right? Shoots off down. So this is a very interesting function. Okay, so now we also need to figure out what's happening at 0. Okay, because there could be something happening here. So it looks like an interesting point. So let's see what happens. So we need to also investigate the limit of g of t as t approaches 0 from the left and the right. So look at what's the limit of g of t as t approaches 0 from the right. So can we plug in? Can we just, so if we look at this function, we can plug in 0 here. There's nothing will break if you plug in t equals 0, right? So t equals 0. This is, so if t equals 0, f of 0 is just 1 over -1, which is -1, right? So as you get, at t equals 0, this function is -1. So oops, this should be something like somewhere here, right? So that means this is actually coming down like this. Oh, sorry, wait a minute, that's not right. This should be here. Well, let's keep it on the same scale. So let's call this -1, right? So it should be somewhere here, right? So I'm just gonna erase this and redraw this, right? So what's actually happening is the function does something like that. Okay, so at t equals 0, the function is 1, and then as it goes to infinity and negative infinity, we know it approaches 0. So this is getting closer and closer to 0 on this side, closer and closer to 0 on that side, and this is what this function looks like, right? And to answer our question, we see that there are 2 infinite discontinuities, right? So we have infinite discontinuities at x equals -1 and 1, and that's about it, right? At 0 it's fine, it's continuous, but this is the general shape of that function. Okay, and I encourage you to plot this out. You can check out, so just go to, I said before, desmos.com and use the graphing calculator and just plot this out. It's really helpful to get a sort of intuitive feel of what some of these functions might look like. Okay, so yeah, hope that was helpful.